Now it's starting.
Let's
Wait,
remove.
let them join back. Wait. They actually asked to remove people from the thing before can join back.
I think some random shit day. Logarithm. That logarithm question, right?
Yeah.
Wait. Their phone can't have
Very
It's
tough
buried
one.
under the books. Hey, that one how hard to do?
Yeah. You have to make assumption, then they can
Wait,
solve.
wait, wait, wait. Just like resend the question again. I forgot. Wait,
Oh,
is the
the
wait. There. Okay, I found it. Okay, wait.
yeah.
So what
Okay,
is that?
now must let Lion come back.
2 log xy plus 2 log yx equals to 5, and then xy is equivalent to 8, and then do
You trying,
simultaneously. Trying now. I didn't do because you sent during exam. What the day preparing for exam? What? How who I want to do? Okay. பொண்ண இது வந்து y square plus log yx square is 5. So then this one tukala log y over
Why?
do we want to keep the base as y, or do we want to keep the base as x? Doesn't matter, right? It literally doesn't matter. Log y x. Yeah, it doesn't matter lah. Plus this one y square log y x
Always
square.
also try the question, just in case.
Alright, so this one 2 lah. So it means 2 over log yx plus log yx square is 5. Right, so now it means I need to put this like this lah. No, but then how you want to son? Susah lah, wait. Let me try this. Log x y.
In the group, always it's in the group a bit.
But then if you to put x, you put x square, you still get 2d. What the hell lah? You get like 2 over log yx
Plus
plus.
you're working, I see. Working can show on the camera.
I think mine it will be inverted d. Wait crap lah day. My wire day. My wires. This is my wires at the back. Literally the amount of wires I have. You can see no. Wait. No, they all inverted days. The other way around.
Inverted, I thought it's okay.
No. Yes, sir.
See again?
Yes.
Okay.
It's upright.
Yeah.
Oh, for me, if you see from my one, is actually the other way around. So like, I'm stuck here, here. Oh my god, my finger. I'm stuck here because now I have 2. So I'm trying to take out the 2, right, and then times 1 over log yx. But is there a way of simplifying it?
I explained on the board easier.
That's why if like what
do I put
let's go.
Actually, can you must use
x negative
quadratic,
1.
is it?
Quadratic. You need the simultaneous linear equation lah.
Never mind. Let the teacher explain lah. Apa lah?
Okay lah. Chill shit. Day. My camera, bro. The hell. The wire all.
Okay. Challenging log question. Okay. So first equation is this: 2 log xy plus 2 log yx equals 5, and then one more is xy equals 8. So if you realize, it was similar to the exam one we got, which was a controversy. Okay, I don't want to tell that again.
Yeah,
it's the same type actually. It's almost the same thing. So okay, so I take this log equation first to start with, log. So let's see. Okay, so from here we can do 2 ways. First thing is we can expand it. Means we make it log x y squared. That's the first way you can think of to proceed from the first equation. The second way is you can inverse the log, which is 2 bracket 1 over log yx. This is the second way. So that you get the same base as this. Then there's something going on there. But what I did is I took out the number 2 here because you see it's a common factor, you would say. So I take out 2 bracket log xy plus log yx equals 5. So by this, I actually reduce doing this power thing and this one. So I shift the 2 over here, become 5 over 2. You see, it looks more simple now on the left-hand side. So then I only do this step, 1 over log yx. I didn't do this initially. I applied it at the third line, 1, 2, 3. Okay, then plus log yx is 5 over 2. So then we make the denominator same, log yx. Then this is the confusing part. Wait, no. So here log yx. So here is log yx. So we put as 1 lah. Because 1 over log yx, you get this one, 1 over log yx. Then you plus. Then this 2. Log yx over 1 means you have to times log yx lah. Log yx. And then on top here, so you have to times again log yx. So you're basically doing log yx times log yx equals 5 over 2. So now here comes the problem lah. First is log yx times log yx. You cannot do like log yx squared. That's the wrong thing. Because based on the rules, when it's times, I don't think we have learned anything like that. So
Yeah.
I don't think so.
Okay.
So we make the assumption here. Let log yx is 8. And just make this one, the whole thing is simplified already. We don't need to look at the log anymore. Make our lives easier. Okay.
Alright.
So then we put the a inside each of the log. 1 plus a bracket a over a equals 5 over 2. So then you see the quadratic coming already. 1 plus a square over a is 5 over 2. So you have up silang.
Yeah.
So 5a is 2 plus 2a square. And then we make it to the general form here. This one you have to remember quadratics chapters basic. So for ours, okay, until here.
Yeah.
No, not for you, Ryan, ours.
What lah?
Oh, like that.
Ah lah, Ryan. Yeah lah, we know lah. You mandal lah. Calm down lah.
Okay, so then we do the factorization, basic one. So you get here a is 1 over 2 and a is 2. So this is not your final answer because we're actually looking what is x and y. X and y equals to what. So when we have this, we put log yx because we made this assumption over here, right? So we put the 2a values inside back here. So it's like a double step. So log yx is half. Then log yx equals to 2. A because a is half and a is 2. And then now we take this equation because you see there's also an x and y term there. So we can derive something from that, which is x equals to 8 over y. Because we realize here, the x here and the x here we can substitute to make it same term with the base y. So that's how we do it. So when we take x is 8 over y, we sub this fifth equation into the third one, log yx equals half. So we get log y, x is this whole thing, 8 over y equals half. And then here is your index law. Everything, whatever law we have learned. So y power half equals 8 over y. This is how it goes to convert logarithmic form to index form. So this is what we are doing here. So then we will get the upsilang again. It's quite long, this method actually. I don't know whether it's an easier one, but it will get the answer eventually. So y half times y power 1 is 8. So we will get y power 3 over 2 because half plus 1 is 3 over 2. So we put it here. So y power 3 over 2 is 8. And then from here, how to solve? Y power 3 over 2, where is it? So we have to square both sides. Because you see, the bottom here is 2, right? So if you square, you cut off the 2. So we will get y power 3 equals 8 square, not 8 only. You have to square the 8 also. So you'll get y power 3 is 64. And then we already noticed that it's a perfect cube. So we can get y equals to 4. So most likely when you get a round number, a whole number like this, your answer is correct in most situations. Not all, but most situations. So y is 4. And then the second one, you have to consider the second possibility. So because there's no negative numbers here, so it's all positive, we have to take into account. So log y 8 over y is 2. And then apply the index law again, y square equals 8 over y. So with the upsilang, you'll get y cube is 8. So y is 2, another whole number. And then now with these two values of y, you're going to substitute it inside this equation. X equals 8 over y. So sub y is 4, x is 8 over 4 is 2. And then sub y equals to 2, x equals 8 over 2, which is 4. So here you will find there is two possible pairs of solutions, which is 2, 4 and 4, 2, right? Inverse something like that. Like when you have the length of the squares, one can be 4, 2, Yeah, like rectangle, not square. 4, 2, 2, 4 like that. Okay, so yeah, that is about it for this question. Ours okay.
Wait. I
If anyone got simpler way to find, can share. I'm not sure.
Nope. I think this is the best. So you get you get y equals 1 y equals 2, another one y equals 4, right? Is it?
Yeah, one y is 2 and
Okay.
another one y is
Yeah,
4.
then you just okay. Thank
Yeah.
you.
wait I'm this one. Wait. So wait, why yeah here 4 then wait how 8 square 64. So wait, so 64 and then you got x is 4. Then when I put there
Nice
so
question.
2 son y2 son. So,
Yeah,
four.
yeah,
So it means wait. So it means the answer is when x is 2, y is 4, and then when
Yeah.
x is 4, y is 2. Like terbalik like that.
Yeah, terbalik only.
Okay.
Yeah.
Uh,
So that's it for this log question.
Mm.
So now we go back
Hey.
to our solution of
the
triangles.
fuller
Okay.
ran away day. You scared the fuller away day.
Eh? I thought he just responded.
Successfully
Hey, oh, he left already.
left. Yeah, successfully
Yeah,
scared
like-
him away day.
Maybe he messaged me. Hey,
Oh my kaduli.
what to do? This kind of questions came, but
Poor nicely lady. Each session I join, his one. I'll talk
Yeah,
something
right.
about him one. I'll talk something about it. I was like, the other day I was like, teacher, this is Anyayam teacher. He teaching
Hey,
us
Sri,
using
Sri.
Latis way. Huh?
We are doing PowerPoint, today. So you can say
Hey,
that.
screw you lah!
I love PowerPoint.
Fuller, you. I told teacher all Indian stuff that what during during the exam day also.
You see,
Teacher,
Adi.
you better be careful. Teacher, he mocking everyone using science. Teacher, you better be careful. Teacher.
Sri, don't be so loud. Kasihan him.
Kesianima. Hey, he never even opened his mic.
No, he cannot open. He's something
He
wrong.
can't open,
Okay, however, it's okay. Have you
Not
heard the
something
whole
wrong.
part?
His mic is something wrong. Bad.
Okay, however, can understand the whole part or not? Or did you cut
Yeah,
off?
we are here. Can you hear us? You
Can
cannot
you
hear us,
hear?
I think. Wait. Let me check. Let me text. Can you hear us?
For you. My supporters.
So. I haven't reached my full potential.
No,
Ryan, I haven't reached my full potential. He left again.
You just said that gone already.
Gone already. No, today.
See?
Stop, I cannot take it.
Can hear not ours.
Call the other fellows to join.
Who?
The others? Taka, you don't tell me you need one mentee day. So many fellows in the group.
Originally was one. I hope we can hear. No. After that, Shri, come on.
Literally, bro. If I get mad, I'll start sending voice messages. Then you know I'm mad. I was like, okay lah, today come, we go school. Right, yesterday, dropped on the bed, woke up, saw the time was like, 12 something. CC, afternoon ready. Very nice.
Am I allowed we start in case don't want to waste time? Just, yeah. So, okay, we start with the recap last sine rule. So, okay, so what is sine rule formula? I don't think you can answer in the chat box.
Cannot lah, must say lah. Shri, answer lah. Answer your.
Sine rule a square equals to b square plus c square
Wait.
minus 2ab. Joking.
You mainly get a slide.
Chill. Sine a over a equals to what? Sine b over b equals to sine c over c.
Yeah, okay, good. Then, okay, so what is the keyword of sine rule?
Keyword of sine rule?
Yeah. I think I told before.
Admats got keyword all.
Whatever, just to remember.
I don't know. I don't know. I look at the question. I just know when to use it.
What is it?
Opposite.
Opposite
Sides and angles. That's how I use when I taught the sine rule. Opposite sides and angles.
I wasn't there at the start. Remember, I only came halfway.
Yeah.
Yeah.
Okay. So what type of triangle we apply in sine rule? What's the type?
God, type of triangle also.
Lower form maths.
Ryan, answer Ryan.
Scalene.
Yeah, correct. Very good.
You.
Yeah, means all the angles are not the same and all the lengths are not the same. That's why you see in sine rule we don't find right angle triangles. You know
Yeah.
why you want to use the sine rule? We can just use the basic trigo ratios we have learned or Pythagoras theorem. So that too is out of here. But we will use the Pythagoras theorem in some of the questions.
Yeah.
Yeah. But basically it's the sine rule and cos rule. Those two are the dominating ones here. So yeah. Next one is this is one how to remember sine rule. So I found a very weird way. I think this one you like a lot.
Remember side rule.
This one is totally for this guy Ryan who came today.
Now only 2 of us your mentee. They trust. They Horace left again.
Okay,
Never
you
mind
found that.
lah. Let him be low. Hiya. Hiya.
Why?
Ryan, I want to see your face.
No. I scared you will come lah. Oh shit.
That's why I'm like, wait, does he know? I was like, wait, does this guy know? Like,
It's okay, right? You're not gonna send. Are you
He's
gonna
not-
send?
Of course I'll
Yeah.
send.
she will
Oh,
send.
oh my
He will
God.
send. She also will watch until each second. Don't worry.
You think she's going to watch it?
Right. Look at WhatsApp. Okay, go on. They continue. They recording.
Okay. So sine rule this is the formula, right? A over sine A is B over sine B, right? So what I give you a tips how to remember this is we are relating it to physics. I found a formula that can help you remember this format of the formula. La. So basically you think of pressure law. This is where the funny part comes.
Boils one, is it?
No, pressure one, not boils. Separate one.
Oh yeah.
Pressure.
X one.
It's FOA, right? Which one? Oh, gay loose egg. Oh,
Because it has the same format. Remember, like P1 over T1 is P2 over T2.
T2. Yeah.
So it's almost the same like this. So why I chose this law instead? Because for Charles also, what? Charles is the same format also, what? So why I
relating the topic?
I say Pascal's principle, Porade.
no, that one not so what horny yet. So this one. Okay, so why I chose this is because of these two words. It is gay means you're committing a sin. So I
I'm sorry.
how you remember.
Oh my God.
This guy.
Just thought of it only. I think this one will have to remember a lot of people can remember now. They think like this. But you have to remember this format first, then they can relate to this. Then but anyway the formula is provided, but just joke thing to remember how to remember this whole. So yeah. That's the sine rule. Wow, she laughs so loud.
That was me trying to keep it in, man.
Why Tanu suddenly? Wow.
Yeah, I say got tuition lah.
Just accept him lah.
No, Ishan joining.
Oh.
Now only came. You missed it. I will explain again for him. Okay. So Ishan, I think can you talk or maybe you can use the chat box. Ishan?
He's definitely there lah. Never mind lah. Just
Yeah, it's okay. Okay. So what we are talking is actually the sine rule. I think you were there when I taught this. This A over sine A equals. It's okay. Just listen. Can type in the chat box. So what I was talking is the sine rule thing. A over sine A equals B over sine B. So how you remember it is actually remember back your physics. Who's joining now? Oh, ours.
Wi-Fi problem, fellow. Wi-Fi problem.
So I asked you guys to remember this physics law. If I don't know whether Horace is studying physics, no, I'm not sure. But this is the law. P1 over T1 is P2 over T2. So why I say this law is because the format is the same. It's something over something equals something over something. So we are relating this A and B is actually lines, length. This represents length. Whenever you have a sine, means it has to pair with an angle. It comes hand in hand. Sine and angle is together always. Same with cos, same with tangent, all the stuff. So why I say this law is, take this one word, gay and sine. So this gay root x law and sine rule. So what I said is, it is gay. It is a scene to be gay. Yeah.
Oh my god.
Actually, E must start off last. A scene to be gay, I think so, something like that. Yeah. So this is how we remember this stuff. We must on something in Malaysia. It's an important word.
Cannot take it anymore. I cannot. You are sounding like that guy who gave the speech, during the. You know what I'm talking about, right?
I hope Ishan can accept this.
He just left, bro. He doesn't accept it. He doesn't accept it. You should have just wrote, it is gay to be a sinner. Dude. Something,
Okay,
something like that is okay. Dude.
Okay, so
it's gay to be a sinner.
Oh, now
it's not as bad, is it?
He's back again. I mean, okay, so
yeah,
that's done.
Peekaboo,
now that's done with that. So now we'll go to basic of sine rule. Now it's PowerPoint time, your favorite time. Preparing for this all night long. Not all night long, pula.
Don't scare me all night long. 5.
Take the copyright from Google. Can see, right?
Yeah.
Then, okay. So we're going to go to the sine rule now.
Hello, what's up, bro?
Oh my god.
Wait, no, that doesn't sound like Ishan. What the hell?
Who is that?
That's Ishan.
No,
yeah.
No, Ishan's right, but it's his
That's
voice.
Ishan, right? No.
I don't think so.
Wow.
The first voice not like that. Okay, go on.
Okay, so we'll start with sine rule, right? So now, I see even the starting they mentioned, which are not right angle, triangles which are not right angle. So we won't use these two rules when it's a right angle triangle. So the aim of these two rules is to find sides and lengths, sides and angles, based on the info provided in the question. So first thing, okay. So let's say we have a triangle ABC, right? So when I said AC, right, means the side will be B because it pairs with the opposite angle label B. Same with here, BC means it's A, pair with A. And then AB, the side will be C, it pairs with C. So, okay. Means we usually use lowercase letters. Since we already use uppercase here, right, ABC, so the sides will be in lowercase A, B, C. Okay, so side A, the opposite vertex. This is what we call as vertex, the side of the triangles, which we actually learned in network in graph theory thing. This is what we call as vertex. Okay, so yeah, that's it here. So quick overview. So this is the rule that we mentioned just now. Basically, this is like we have two equals, right? Usually we'll only take up till this part only. A over sine A is B over sine B. We won't involve the C over sine C thing because usually the question will give you 3 info, then you find one of it only. Okay, so yeah, then they told here, only use one of it in reality. Okay, cosine rule we won't do yet, so we go sine rule first. Oh no. Okay. This one. I'm not sure about this, but I don't know whether they're going to ask this in SPM, prove the sine rule. I'm not sure, but safe just to know how it came, this rule, just in case. So let this triangle ABC. So we have this length, right? AC is B, and then the opposite vertex is B. So you can see here C, B, and then here is A, opposite is A. So that's the same thing. So what we're going to do is divide this one triangle to form two separate triangles. Because from there only you can get simultaneous and then make it equal to one another and form a sine rule. This is how the whole formula came about. So it's basically a formation of two separate triangles from one large triangle. So what they did is actually draw the height of the triangle to separate it, because that's the best way to separate the triangle by using the height. So okay, so far everyone.
Can.
Okay, so we let this length AD equals how can I say let length AD equals H? Something wrong, should be CD lah. Let CD equals H. So we focus on one triangle first, which is BDC, this triangle over here on the right. So since it's sine rule, right, you want to derive it, so you have to use the sine function, of course. So it's sine B. So is this the angle here, right? So if you want to find sine B, we have to take opposite over hypotenuse. This is the basic trigonometry ratio we learn in Form 3. So the opposite is this CD, because C opposite to this angle. Straight away opposite. So we take H over the hypotenuse. Hypotenuse is not involved in the formation of right angle. So hypotenuse will be CB. So we label A. So we see the common thing here is the H, right? That straight line down there. So we will make H as the subject of the formula. And then we shift this up here. So H is A sine B. And then in the other separate triangle ACD, we take sine A instead. We take this sine. This side we won't take. We won't take sine C, because you see here we don't have this separate length here AD. We won't. We cannot find it, but actually can find but it's square root B square minus H square. So I don't think we want to find that So yeah, we take sine A. So sine A is H over B. And then we make H also subject of formula B sine A. So there you see, suddenly you realize that something is going to happen here. You can see the sine rule coming from this part itself already.
Yeah.
So we make 1 is 2, and then we make the ratio of length to angles equals to the ratio of length to angles. So this is how sine rule comes from. Basically, it's just a ratio of length to angles. So yeah. That's your sine rule. So everyone okay? I better go back in case got questions. Should we go on already?
No lah.
Ishan okay, everyone?
Don't worry. I'm still here, bro. Don't worry. Might have to leave soon, but not now. Apparently, Dad's on the way. So.
Oh. Safe journey.
Thank you.
Okay, so next one. So now we are applying already straight away this formula. Besides, this chapter is very simple. You master the formula, you solve the question straight. It's like very direct. There's no what you call interrelation between questions. It will be like one specific formula for one question. You cannot see it from different perspectives. It's like very straightforward stuff. Find the length, find the area. And then another possible question is they will ask you to sketch a different type of triangle that can be formed. That's the three main things you will see in your exam. So that's the thing. So next one. So now we study this diagram together. So they gave this one. This one all is provided already in the exam. So let's see. Okay. So you see here, what can you interpret from this diagram? Anyone? Ishan also can. What will you interpret?
We can find the other angle, and then we can find X also.
So like the angle that is opposite to the length is like
Yeah.
the A and capital A,
Quite a
or
lot
no,
of
B and
things.
capital B.
Yeah, correct. So
And the capital
basically,
B will be your angle, and the small b will be your length.
Yeah, correct.
Yeah.
So you see here, there is one unknown X here. So what we are going to find is this X. So you see the opposite pairs, opposite length paired to opposite angle, opposite length paired to the opposite angle. So yeah, so now note that the third angle C and its opposite side C is not used. Why? Because we don't have any information here. Actually, wait, let me think. No way lah, cannot. Or you can find this angle lah, but it's no point because you want to find x anyway.
Yeah.
So yeah, so we just do directly these two.
Mhm.
Okay, so this is it. And then we now use this formula lah. So make sure you like list down all the info before you solve the question, no? So that you know where you should sub. Don't sub like opposite. Let's say sine 54, you misplace it and put under the x over sine 54. So that can happen if you're rushing in the exam, no? It's not impossible. It can happen also. So 12 over sine 54 equals x over sine 88, sine b. No? So then we do the cross multiply. Whenever you get like this, how to solve it is you must cross multiply. Means you do an x sign over the equals. That's how you can get your x. It's basic algebra. So x you will get 12 sine 88 over sine 54. This case they put 2 decimal place only, but I think better for right, Ryan?
Yep.
Yeah. So not the what KSSM formatting, it's just a random slide only. So yeah, it's not according to our format. So okay, so this is the thing. So make sure you also know how to press in your calculator. Wait, let me try to show. Because this thing, your calculator is your lifeline. If you don't bring calculator to exam, you are not going to solve this question. There's no way. Okay, so wait, stop present first.
Wait, I just wanted to ask: is it true that during like what SPM they won't allow you to bring like the back part of your like calculator or something? I mean, not that my calculator.
That one you must ask Ishwa. Ishwa's calculator is the best example. If that one can pass, anything can pass.
Oh my god, why lah? Okay.
Because of the stickers behind the calculator, of course.
No, because because some calculators the formulas are all at the back, you know. Formula,
like this
constant
one.
and everything.
This
So
one,
like my
right?
calculator all it's
Yeah.
like
Sun
on
got-
the screen lah for me. So I just wanted to ask for those who
Yeah, it
have-
might not be able to actually because got the conversion.
because when I
symbol.
asked my sister, she was like, "No, my SPM timer didn't allow to bring the back part.
Really?
So you have to leave it in your bag."
Wow. So I just show how to press it. Okay, let's see. This question they said is 12 sine 58 over sine 54, right? So I hope it's clear here. 12. So 12 normally I have to show like this. I cannot see directly and press 12. You can put sine directly here, or you can put times symbol sine. What was it? 88 lah, let's say times sine 88. Okay, so it comes like this. Or you can put as 12 sine 88 directly. No need the time sign. It's the same thing. You'll get the same value. But what is the difference is you press equals first, get the answer. Then only you divide the another angle. Make sure it's in bracket just in case. Especially when you do your cosine rule, because the formula is long. And then negative stuff can make it go wrong. So sine and then let's say a random angle 55. Like this is how it look in your calculator. So make sure those two brackets are there, then only can. So there you get your length of side, 14.64. Usually take up till 4 decimals. 14.6404. So you round off the last one. So I think most of y'all use this model, but sometimes got the Chang'e one, I'm not sure. So this is how we use it. Okay. Okay, so now we go to the next one. Next slide.
Day, good news day. Going
Why?
later only day. After class only going day.
Very good.
After class only going. Okay.
Okay, so now we continue this one. Okay, so this one done. Okay, next example. Yeah, same thing. So basic thing. This one all don't need to read. This one's like very lengthy stuff. But what we need to know is how to apply the rule only. So x, you must over the angle sine 22 equals to another pair of opposite sides and lengths 35 over sine 95. So this is how you do it. Make this one equals to this one. So how they solve it is like this. 35 over sine 95 equals x over sine 22. So you'll get you cross multiply, you will get 35 sine 22 equals x sine 95. So again, this x, right, make sure it's in 4 decimal places, not only 2 decimal places. So this your x. And then yeah, this one. Okay, wait. Okay, now you try this one. Anyone? This question. I must come there to see. Who want to try now? Three?
Yeah, wait, which question? Is it in the group?
No, they're here. This one.
Okay, because I couldn't see the question. Alright, hold up. Wait. My this one very nice. Wait. Laptop.
Others
Okay.
also try, yeah. Ishan and Horace.
What is that? So which one do you want? They want theta. They question.
I better scam inside, guys.
Wait, let me sketch first, then you see how much you want. Wait.
Yeah.
Theta and then what 4.7, 5.1. Okay, lah, can. Okay, you see
Yeah,
how much
just send this inside the group in case
okay.
lagging or what. So anyone get the answers first? You just share it then. Make sure 4 decimal places, everyone. This is the question.
Today 54.4587. Brother, muted. You're muted.
Wait, hold on your answer.
Okay. All I could know is that you were trying to say something.
What you thought I was going to say?
I thought you were telling me if the answer is right or not.
Oh.
Because your mouth is
Horace,
covered
you
with your
just
body.
try first the question I sent.
There's another question of it.
No, Horace.
Oh, horrors.
This one will be very useful for everyone. This thing. So you put your answer in the chat box so that I can compare later when Horace type. Later I forget your answer.
Okay.
Horace, you try to solve first, okay? Don't use that answer directly.
You just ask me for the answer. I just press one button. I can send it. Don't worry.
Oh.
Yeah. Anti cheat system, bro. Let's go.
If you're stuck, you must tell. I think Ryan AFK already.
Yeah, I mean, he did mute his mic, so.
No, I'm here.
Wow. This one actually should be the easiest question to score in your section C. So you see solution of triangles, try choosing it.
Right.
As long as it's not in 3D diagram, that's the one even I also sometimes find it difficult, the 3D stuff. As long as it's in 2D, it is solvable. If 3D, sometimes there is a chance to go wrong. Depends how you view it.
Right. Actually, I haven't done any of those 3D stuff.
81. What you said 3 just now?
My answer, this answer.
Wait, let's confirm and see the next slide. Moment of truth.
Moment of truth. CC, I'm wrong. For you.
I scared CC you wrong.
Yeah, I
Let's
think
see.
I'm wrong, day.
You see the ad come. Ooh. Sui lah. Right.
Let's go.
Okay, so ours, make sure you just like follow the steps.
80.
This identity
Did you
can-
forget to divide 5.1? No, but then you get different. That's a very high number. I mean,
I'm not sure how we
sine.
made.
No, wait. Inverse sine. No, cannot be. That is 0.
If you identify your mistake, you can tell that I can see it. So see which part to correct you.
Did check your angle? Did you put any other angle by any chance? Instead of
Any
62,
other
you put something
angle?
else.
Why?
That's the only thing I can think of.
Oh, the mistake he made lah.
Either
Oh.
he like copied down the angle or something wrong.
If you know how to use, maybe one more thing I suspect is the inverse function thing. Do you know how to use it in your calculator or not? That's one thing you have to
The
know.
inverse function, you sign 0 point something will get.
Yeah, I know, but depends on the
score.
model of calculator. Sometimes might be
Depends
seal
on
up
the
a bit.
model. Okay.
If always you know your mistake already, then it's okay lah. You just tell me, then I will proceed already. Things should be okay. So we continue again. Inform me, Ashri, if he says anything.
Okay.
Okay, so next one. This is the fourth example. I think everyone mastered this already. It's okay. So I think this is the same thing only. Oh, but this time they asked to find extra. Same thing lah. Where not the same. You have to find this first. This is the extra step. Because you see here, x is here, and then we need this angle here. So we don't know what is this angle exactly here. So what you have to do is 180 minus 68 minus 33. Then only we can find this. Then only you can apply the sine rule because you don't have this length here. This length is missing. If not, you can already find the x. So you take x over sine 79 is 35.7 over sine 68. So from here, you darab silang. 35.7 sine 79 over sine 68. Again, 4 decimal places, not 2. So x is something 37.80 something. That's what you will get. So I hope you know how to press this in the calculator. So I think this one shouldn't be a problem. The only thing is you want to find the angle from the lengths given because you have to use the shift sign stuff. So that one, make sure you know. Okay, so this is the new part, ambiguous case. Okay, so this one I think this one is the best part of the sine rule. Most challenging part. Wait, Sri, what happened to your mic? You are talking, but
I'm here. Just
I thought you were talking, but this thing not capturing your sound because it was moving.
Think be weird like that.
Okay. So now we go ambiguous case. Okay. So Ashri lah. Okay, what do you think about ambiguous case? What can you define it as?
It's more okay. Ambiguous case in like from what I understand is that from one triangle you're able to create another triangle. Doesn't matter if the triangle is within that said triangle or you create another one outside.
Yeah.
Right? But most of the time the ambiguous triangle that you're making is usually isosceles because the height will be the same. Right.
That's what I mentioned last week.
Yeah, that's what
That's the basic idea.
I understand. And then, but your ambiguous triangle, sometimes your angle there can be like 180 minus that angle.
Yeah.
And then you get a larger angle. So, it's,
that's the correct understanding. Okay, so ask Ryan. Let's see how he defines.
I don't know. I think like that lah.
Same,
Okay. Yeah.
Okay, so that's the right thing. Exactly what I said actually last week. That day, not last week, the day before the exams. So okay, now we start. Okay, ambiguous case. So now what we are going to do is from one triangle itself, we are going to form two triangles. So this is the idea we have to generate. And this question, you can already expect it will be coming in your section C. Any question lah. So If you get this, if you learn this, then definitely you can score 10 marks a day if you master this. Because the before ones all are basic, using formula only. This is the most challenging part in this question. So, draw two different shaped triangles ABC in which they give you these conditions here. So you have to obey to them. This is how the question actually will say: sketch a different triangle, let's say ABC prime, in which they will tell the length of sides equals to what, and then maybe one angle equals to what. So this is how they solve it. You see, there's a possibility here that you can form an isosceles here, because you see, obeying the ambiguous case rule, like the non-included angle stuff here. So when you drag this down here, you will form C2, or we can call it C prime also. Here they use C1 and C2. Usually we use C and C prime, same stuff. So has no okay, takes time, okay, extend a side, okay. So now we extend side AC1 past the C. Then only we have a chance to intersect this line with this line. So the new point where we intersect, the length is BC2, which is the same as the BC1 because it's an isosceles triangle. So this one is 10 cm over here, and then this one we extend. So this is how it looks here. So the new triangle ABC2, this whole big triangle here, same properties as the original one, ABC1, because it's the same angle and same length, so nothing will be changing. But one thing that is different is the angles at C. This one, these two angles over here. One is acute, and another one is obtuse. So yeah, that's this is the obtuse one. The side one over here, you can see directly from the diagram. These two will be acute. 180 minus either one of these is this angle over here. Okay, so next one. Okay, yeah, so that's why I said. So what they say? How are the two angles C related? Okay, so okay, what do you all think? How are the two angles related? See? See? Ryan? If always have your idea, you can give also how are the angles related, these two. These two triangles, how their angles are related. You see here is this angle 180 minus the theta only that's how it's related actually. So yeah, this is how it goes, the relation. So you see here, ABC, this is why I told the angle is obtuse between the AC1B. So this is the angle that's obtuse, and then this one here. So angle C here will be acute. This is the one where I do the isosceles here. So this one is acute, this one that forms 10 meter. So how they are related is 180 minus theta only. So one is theta, one is 180 minus theta. So the green one is the acute angle C2. And then the blue one is the obtuse angle 180 minus theta. So what we call this type of angles is whenever you have an angle plus another angle, we call it as supplementary angles. So this is the name for the angles, supplementary, because it's something plus something is 180. And then for this one, first for one, if one solution is 73, this one is 73 here. The other one is 107. So we can find it based on the sine rule. 14 meter over sine C3, sine C2 equals to 10 meter over sine 32. So that's how we find these angles over here. So yeah, that's how it goes. This is the part. And then yeah, so here we have two chances actually, because we can have an acute angle or an obtuse angle. So usually the question will mention find the they'll say in the question, the top part, given that angle AC2B is an obtuse angle. So from there, you only can accept one answer and then you reject another one, which is this one, 47.9, because it is not obtuse. So this is the one, 132.1 degrees. That's the solutions. So, okay, this is the summary of the sine rule. So, always okay. I hope you can hear. Okay, so this is how it goes, this whole thing. So the idea is basically sine rule. So sine rule, the whole thing is this the basic trigo function that we have learned so far, which is sine rule. So okay, one. So we see here, this one, the sine rule goes like this, where the formula is actually A over sine A is B over sine B equals C over sine C. And then to use the sine rule, we have few rules. So the rule is matching angle and opposite side pair, two pairs. So then the next one is a third is given, a third side or angle or an unknown, which also make an angle. So yeah, this is the thing. And then the next one is when asked to find size of an angle, you have to check the problem whether it involves ambiguous case or not. So we'll see example 5 later. In the case two angles are supplementary, means they add 280 degrees. So next one, when confronted the problem whether to use sine rule or cos rule, means you have to apply the sine rule first because it's the basic formula over here. So let's see this one. So you have to use sine rule always because the basic one. Basically cosine rule is maybe I will say derive after the sine rule. So sine rule is the most basic one. Okay, so the next one, in every triangle, the largest side is always opposite to the largest angle. This is a fact. So the side lengths are the ratio of the sines of the opposite angles. This is what the formula explains actually, using the concept of ratio. So that is basically sine rule. Another keyword that can make you remember sine rule also is actually ratio, besides the thing I told earlier. So, okay. So next one. So this one is one of it. Then sine rule summary. So this is how actually we derive the formula just now. So largest side is opposite to largest angle. Middle size angle is opposite to the middle size angle, and smallest side is always opposite to smallest angle. So the ratio of any two side lengths is equal to ratio of sines of their respective opposite angles. So A over sine A is equal to B over sine B. So C over sine C is also equal to A over sine A, opposite sides and angles. So they are just reshaped versions of the original sine formula. So you can modify this formula any way you want, as long you can find all the components of the triangle, which are the lengths and sides. This one, next one, cosine rule already. Wait. Stop first.
Yeah, buddy.
Okay,
Yeah, yeah.
Okay, so next one. Wait, let me see. What do you want to do now? Tell me which topic you want.
Me,
Hmm.
Uh, I okay, wait.
Wait, let me
Mm,
see.
Wait, you're doing until 6, right? 6:30.
Yeah.
6:30.
Yeah.
Let me think.
So
Why?
30 minutes.
Mhm.
We're doing advanced for 30 minutes.
Vectors.
Vectors.
Vectors. Yeah lah.
Or
For me, I would say the parallel and the non-parallel shit lah. Not gonna lie.
Yo,
The
that
vector,
one.
vector lah. I don't know what that is, bro.
That one, I have to actually learn a bit first, lah. Then I can come
That's
and
why all of us
talk in
forget
one year.
already. Oh,
That's
super
why.
already. One means what lah? We can do the
I do
what,
cosine rule, lah. We continue cosine straight.
can lah. Or
Yeah.
if say you want a change of pace for vector means then you can teach the simultaneous linear equation lah.
Oh, that one. Then might as well teach
For
the
vector.
chapter 3, lah. The concept is there. The
Hey,
concept is
30
everything
minutes.
is there.
30 minutes. How are you gonna finish chapter 3 now?
I think better not do cosine rule. Cosine rule can
That's why lah.
finish.
Up
We
here, up
derive the whole cosine rule formula. The
Two.
most complicated formula we have
The
seen
fact
so
that you
far.
remember that is already amazing, don't you think?
What?
That you know how to derive it. I just
No, I never
memorized the
remember.
formulas.
Everything.
Apne.
How to do?
No.
How to do?
I had hopes for you, but I had
I try
hopes.
to learn a bit, lah.
Okay lah.
But actually, basically, it's the Pythagoras theorem stuff only, lah. They apply in the cosine rule. So we start
yes,
with a bit of understanding, lah. We understand this cosine rule first. We don't have to go straight to deriving first, or else we get much mental block.
Mental block.
Okay, so cosine rule, right? So can you see there is a similarity actually in the word itself? Cosine means there's something related to sine, right? So they call it cosine. So actually, what is the relation is they are complementary angles. I think we have studied this in Trigo, chapter 6. So they call it cosine rule.
Okay, wait. So complementary angles are the angles that are plus together, and then you get how much again?
90.
90. Then supplementary is 180 lah. If you
Yeah, correct.
Right,
Supplementary
okay.
180. So yeah, so that's why they call it cosine. That's why the word co in front there. And also, if you like relate it to English, you see, maths means there's like sharing something, So let's say we have like co-insurance. Remember, we have co-insurance. Yeah. So basically, is we share the percentage. Let's say 80% from the what is that? Insurance company. And then 20% is from the policy holder. So this is the concept we are using here in cosine rule. Because you see sine, let's say we take sine 30 and we press equals to cos 60, you will actually get the same answer.
Same thing.
Same thing. So that's why they call it complementary angles. Means they complement each other. So that's how
brother, restart. Fleur came back.
But restart. Oh, restart the thing. Okay. So okay, we are doing cosine rule now. We study the next thing. Wait, battery low. Wait, might not be able to see it, but just try. Okay, so now we do cos. I don't know whether you can see it. Can
Horus. For me, can lah. Horus.
Okay. Now, okay. Okay, so
right.
cosine rule, we sharing the angles, right? So cosine rule, wait, let me think. Okay, so we do a diagram to understand it. So let's say we have an angle, cannot this one. This one is 180. So we take like this, then we divide like this. Here, let's say it's 40. And then here will be automatically 50 if these are right angles, right? So yeah, that's the thing. So let's say you want to take sine here, and then you want to take cos here. So actually what you will get is, let's say the length here is 5, and then the length here is 4. And then here we can find the hypotenuse, basically, isn't it? 5 square plus 4 square, you will get 41, cert 41. So now we can apply sine 40 equals to, actually it cannot work this thing, but yeah, that's just the concept. Can't use calculation to prove this because the ratios are not correct. So cosine rule is basically related to sine. That's what I'm going to bring out here. And why I also say this is the word co. So whenever you see something as co, means it's sharing something based on the English term like co-worker.
Right.
Yeah, that's how you understand it. So cosine rule actually is related to sine rule in terms of this part. But the formula is like very different. That's why it makes you think it's something very different compared to sine. Actually, they are interrelated. Around there. You can put arrows like this, back and forward. Okay, so now we will do deriving this whole rule. Wait, one more thing. I want you to realize also something like in chapter 8, right? So the basic ones of trigo function we have is sine, cos, tangent, right? Isn't it? Sine, cosine, and tangent. So what we're actually doing here is we add a co in front to everything. This is how you get 6 trigonometric functions. Remember in chapter 6 trigo we have cosine. No, this cos cannot come here. Sorry. This one is secant. So you have sine, secant, and tangent. This is the basic ones. So from there we derive 3 more new ones, which is cosine, cosecant, and tangent. This one is not used in this chapter, but hey, tangent, not cotangent, not tangent. So what we actually add is the word co in front here, means it's derived from these 3 basic ones. Sine, cosine is derived from sine, cosecant is derived from secant, and cotangent is derived from tangent. So this is the thing we are using here to relate everything.
Right.
Yeah. So this is how you understand. Means so you see in the trigo, right? Sine and cosine is related by the 90, right? Remember?
Sine and cosine. Yeah, la, by the
Yeah.
90 lah.
And then secant and cosecant.
180 lah then.
Yeah, and then tangent and cotangent. Yeah. So that's why you see it's related.
Right, right.
So you have the formula tangent theta is 1 over cotangent theta. So you see it's related.
Yeah.
So this is the thing relating chapter 6 to this. So I don't want to enter that yet. We just do cosine rule first.
Okay.
So now we do the hardest part, derive formula.
Derive formula.
I don't know whether they'll actually ask that or not in the exam.
I actually really doubt lah, because like your trigonometry itself got proving ready ma, left and right side.
I'm not
so
sure.
like I really doubt lah.
Yeah.
Not good.
Just not for knowledge purpose. Because I don't like we have to accept the formula is like this. So we have to know how this formula comes from actually. Not just accepting it as it is. So it was so long to remember what a square equals b square plus c square minus 2bc cos a. But actually this complex thing is actually formed from simple things like Pythagoras, trigonometric ratio. Then only we can form this whole long equation. So that's how we are doing it now. So let's see, cosine rule. What else to tell? Let me think. Okay, now I'll just write the concepts first. First, we are going to use is Pythagoras. And then the second one is trigo ratios. So this is how cosine rule comes about. So in your textbook, you will see, right, there's 3 types how cosine rule goes, right? But we'll finally use one way only. So usually a square is b square plus c square minus 2bc cos a. Or the other two is b square equals a square plus c square minus 2ac cos b. Yeah. And then the other one,
c square equals to a square plus b square minus 2ab.
2ab cos c. So what we actually find similarities here is, why I say Pythagoras is, you notice the front here. A square is b square plus c square, b square is a square plus c square, and b square is a square plus b square. You see, the front part of the formula actually is Pythagoras theorem. Now this is how the relation comes from. Then only they form this whole complex thing. That's why we don't apply to 90-degree triangles. What? You apply to 90-degree triangle, you cos 90, what you get? 0, right? You cos 90.
Cos 90, yeah. 0, 0.
So if you cos 90 0, this whole thing cancel already. Minus 2, all that, all nothing. What? So that you get your Pythagoras theorem. Whole thing at the side here comes 0. What? So this is your Pythagoras theorem. See how cosine rule comes back to Pythagoras theorem from a complex thing to just a basic thing we learn in lower form. So that's the thing. So this how now we are going to learn how to accept it, lah. The whole rule itself, the
Mhm.
whole cosine rule. So yeah, it's the basic. I hope after this you don't get mental block. After driving this whole thing. It was quite
Hopefully.
long actually. Sine rule was actually quite short, but this one is
Yeah.
longer.
The moment you put Pythagoras theorem into like proving, it's
Yeah.
it's gonna be long because of all the
Yeah.
I
But that's how you
I
form
generally thought
complicated
because of the
things.
squares.
What complicated things just can't come like that. You have to form from simple things and then you come complicated. That's how it comes out. The formula comes. What?
Like that lah, buan anoblism all.
What?
Anoblism all. Simple to complex all.
Why are you going to bio?
That's the only thing I remember.
Okay, so triangle ABC. Let's say we have to assume lah. When you make these formulas, right, you have a lot of assumptions you have to make before we start the calculations. So let's say we have a triangle ABC, right? So this length is A, right? Because it's between B and C. Then this one AC will be B, right? And then AB will be C, based on the opposite angles. So this is how we label first, and then we will draw this height here. This is the height of the triangle. Remember, this will be the height. And one more question. This one they like to ask in the exam. Height actually represents the shortest distance. This came out in the exam, right?
Wait, which one? I'm confused.
Yeah,
What?
shortest distance in the solution of triangle.
Yes.
Yeah.
Shorten distance, then automatically 90 degrees. Lah.
Yeah. So this is the concept of height of triangle. It's actually the shortest distance from A to BC. So this one I want to bring out here. So
Right.
because it's the important thing they'll ask in the exam. So yeah. Next thing. Now we can start the whole divide. So what they did first is actually they made one thing as x. So let's say here is x, right? So here this whole length is A, this is x, means here will be A minus x. So you see how the formula starts to develop. You have to start with this assumption. If you don't start putting x here, you will go nowhere in this formula. So yeah, this is the starting. And then here is 90 degrees, remember. So that's why we're using our trigo ratios. So if you would like to derive it, how will you start? What's your first action? This is what we want to get eventually. A square is B square plus C square minus 2BC cos A. How will you start to derive this formula? Your first action. What do you think? Me?
I have no idea. I'm trying to think, but I have no idea.
Okay, now we follow the textbook. Okay, so we see, right, there's two triangles here, right? 1 and 2 here, one big one, one small one. So what we actually do is we'll use first the Pythagoras theorem, step 1. Think of Pythagoras theorem first. Because it's 90 degrees triangle, but when you cut this with the height, two 90-degree triangles are formed already. So let's say we start with this triangle A. Let's say I call this C prime, down here. A C prime C. So let's say in the triangle AC prime C, the Pythagoras theorem would be this, the hypotenuse, right? The B length. So B square equals to height H square plus A minus X. Only this length, remember, not the A length, only this side. Plus A minus X square. So now you can see how complicated it comes, right?
Yeah.
B square equals H square plus A minus X square. So that's how it comes complicated. Okay, let me think. So we expand the bracket. They actually expand the bracket. So B square is H square plus A square. When you get this pattern, try expanding directly from here. Don't open it into two brackets because it will take more time. So plus A square minus 2AX plus X square. Now we can see how complex, right, actually?
Yeah.
Okay, so this is your first equation. Okay, so this is the first equation. Next, you have to consider this triangle pulang ABC prime. Triangle ABC prime. So same concept. We use Pythagoras also again. So C, this length is C, right? So C square equals to x, this length only, x square plus h square. See, these are the more simple. C square is x square plus h square. So this is your second equation. Wait. Yeah, okay. This is your second equation. So what we are going to do is actually sub the second equation into the first equation. Because see, this is a simple one, right? And then this is the more complex one, isn't it? So we will sub the more simple one into the complex one. So how to sub is you have to find a common term here. So what do you think you want to sub from c square is h square plus x square? What variable you want to sub inside 3?
Wait. I'm a bit lost. Wait. Just now you said what c square equals to what again?
X square plus h square.
What variable? Wait. What's the question again? I'm
What
confused.
variable you want to make the subject of formula, then you sub into the first equation.
Oh,
Cx or h.
I mean, define. I would say x because that's the angle, right?
Not wrong. I wouldn't say it's wrong, but one thing you cannot do is because here you see, right, the first formula is b square equals h square plus a square minus 2ax only. Because if you put x square means you have to square root the whole thing, then only sub. It's more difficult. Right?
Difficult, right? So h lah.
Yeah, definitely h. Because see h, you see there's only one h here, h square. So it just basically subtract there. So we shift this formula, we will get c square minus x square. This is the third equation. Now I don't need to put third equation, you get more complex. Just put it as the second one. That can be the second one. So we sub 2 in 1. Sub 2 into 1. So what we will get? Oh, it's going to get more complex.
Oh.
Okay, sub inside here. B square equals c square minus x square plus a square minus 2ax plus x square. Wow.
What is this?
This is the textbook. This is how they do it.
Right.
So now we have to wait, let me think. Okay. Cancel the x because we have x square, right? C square minus x square, then here we have plus x square. So we cancel this x square out. And then we will get c square plus a square plus minus 2ax. So b square is this. So you see it's something coming close already, right? You can see here based on this formula, I think. So, Ryan has to come. Why this guy going toilet? No, never mind. Okay, so this one, right? So we continue first. Now we already get this. Now we have to apply cos law. You have to find an angle that can sub inside here. So we are going to ganti this x with something because you see the formula has no x inside here. So you have to substitute this x with something. Sub x with trigo ratio. One of the trigo ratio. So what this is cosine rule, we'll use cos law. So which angle we are going to choose is an angle which has only x. So this side. And then cos means adjacent or hypotenuse means C. Means we're going to consider this angle here. Cos B. So cos B is equal to adjacent over hypotenuse. Adjacent is x. Hypotenuse is C. So we shift the formula, we will get C equals to, wait, let me see, correct? No. X equals C cos B, yeah, correct. X equals C cos B. So this is the third equation. So third one, we will sub into the second one. So now we sub back inside here. So B square equals to C square plus A square minus 2ax is C cos B. Okay. C cos B. So you get B square is C square plus A square minus 2ac cos B. And this also has another formula on top here, which is B square equals A square plus C square minus 2ac cos B. Similar. It is proven. This is the formula. So this is how we derive the whole formula, the whole steps we use. So basically, it's master your simultaneous. This method we use here is substitution method. You don't do the left 1 equals to 2. So make sure you master using substitution method. That's how we solve this question, substitution. And another thing we have to apply is trigo ratio. So there's two things involved here in this rule. Then only you can derive this formula. First thing, substitution method. Second thing is trigo ratios. So trigo ratios comes here. Then you get this whole formula right here. So it can be in any formula. A square is b square plus c square, or b square is c square plus a square, or the other way around. So yeah, this is how we derive the formula. This is the whole thing. This is cosine rule. So the whole formula actually comes from there. So now you will go to the PowerPoint on cosine rule. This one. Right? Okay, so now we'll share screen. We'll go to cosine rule. So this is the cosine rule. So let's go. Okay, so cosine rule. Okay, so sometimes sine rule is not enough to help us solve not right angle triangles. So why they say this is actually because sometimes they will give you two sides and one angle which is not an opposite. It's not an opposite side to the angle. So that's why we apply cosine rule here. So why do we apply cosine rule to this triangle? Is you see, we cannot use sine rule. We don't have two angles here. Sine rule must have at least either one of these two angles or two lines, two lengths lah. Two angles or two lines. Here you have only one angle, but you have two lengths. And based on this formula over here, you see we only need one angle cos B, and then two lengths of side C and A. Then we can find another side. So see here, when we use sine rule, A over sine 30, A over sine 30 is 14 over sine B equals 18 over sine C. So you can see the unknowns developing here. There are three unknowns, which consists of two angles and one side. So this is the problem we face here in cosine when using sine rule, because it's too basic. That's why we created a more complex formula called cosine rule to solve various problems. So this is the first thing. And here we have these three formulas over here. So we derive another cosine rule. So cosine rule is actually derived. It's not just like that. Okay, so we go on here. So cosine rule, minimum requirements, two sides and an included angle given, or three sides are given straight away. So if we have three sides here, we can find the angle here, either angle C, angle B, or angle A. Because we only need to find one angle in this case, only one. So if we have all the three sides, good luck, we can only find what angle we want. But if we don't have all the three sides, we want to find a side, we have to have an angle. At least if you have one angle, that is enough. If you have two, better, you have more choices to pick from to find a particular side. So you see, there are three sides to the cosine rule. Depends which one you want to use, but actually these are the same three stuff actually. They are repeating the same concept. Right. It's just they use different letters to represent the sides or angles we want. Right. Oh my god, it now came, huh?
No, I was sitting here for quite some time already. Yeah, but
do you see how I derived the whole thing? Okay,
you took photo and sent in the group, right?
Not yet, I didn't send yet.
Not yet. I mean, quite long. I have to look at it again to actually understand. A bit blurry, like you just take photo and send. It's okay.
Okay, continue here. This one. Hey, stop sharing.
Stop share. Why?
I
Oh,
stopped
six-
there accidentally.
Oh, okay.
I'm using PowerPoint.
Right.
Cosine rule PowerPoint. Okay, so this one here. Here. So usually we get complicated, right? When we see three stuff like this, just use one formula enough. They don't complicate yourself with three formulas. Just remember one and then proceed with it. As long you know how to apply it, like based on triangle. One more method I found. Okay, I share this method. Maybe it might help.
For you.
How to use the formula an easier way, just like don't use it as it is, so let's see. We just give a random example, a normal triangle, and then we see how we use the formula. So let's say I have this kind of triangle. The triangle looks like this. So A, B, and C. So what I do is actually draw a stickman. You know, actually
Man, I have no idea this is your
okay, stickman, right? How we apply stickman into this is put the head here, put his body. These are the two legs. Comes to the side. From one, let's say we want to at this angle B, let's say. So what we want to find is AC, right? So AC is actually opposite to the stickman's legs, which are AB and BC. So that's why we put AC, which is known as side B, right? We put B square. And then here BA, right? So we put as side C. So C square. And then BC is A. So then A square, because two legs. The one on the right side is two legs actually. See this stickman over here and here, isn't it? So we get these two legs over here. And then we minus, so you remember the formula, 2 and then AC. You have to repeat the equation on the right hand side again. Minus 2 AC. Then cos the angle where the stickman is E. So I think now we can understand how to use this rule.
So this is a method of how to implement it, not like a whole different formula.
You can use it for triangle.
Right.
Triangle also can. So basically, whenever they ask find angle B, draw a stickman at B, then you see where the legs are. And then the opposite side is where you put your B square equals to the whole thing. So that's how you do it. See, with the stickman, you can already come up with a whole formula of cosine rule. Mind blowing, right?
Alright, I think I got to go already. Hey, Ryan Chang left already.
Huh?
Yeah, Ryan left already.
Just finish the PowerPoint, then you can stop. Going to finish.
I have to go. I have to go put all my stuff in the car now.
Okay, let me see how far it is. Okay, so this one we skip. This one we know already. Just shift. This one nothing. Let me see. Questions only lah. Maybe we keep this for next week. The questions.
No, you just put the question in the group lah.
Yeah. I'll send the slides so that anyone can like try and then solve it. Then we discuss it next week lah.
Yeah.
Okay. Open your camera and take picture.
Oh, brother. Why, brother? Hey,
Come to Vijaya.
Alright.
I
don't know what.
Going to Alostar. Okay.
Alright, bro. Good job for today.
Done. Thank you.